Okay, welcome everybody to the presentation DB309. What a coincidence, DB309 in B309. So they have coincided the room number with the presentation. They tried to coincide the time also. The closest time they got is about 3:15. There was no session starting at 3:09. Otherwise, we would have got that session as well. Welcome you. My name is Sanjay Mishra. I'm from Microsoft. I work in a team called Customer Advisory Team inside the SQL product group. We are a small team within the product group which is focused on spending time with customers. By spending time with customers, we help them choose the right solution, help them with their architecture review, and in the process learn what is working and what is not working for them. What is working for them is a best practice, presentation like here, what we are doing today, and what is not working for them is a product improvement that goes into our next product. And my colleague Prem Mehra is not here with us today. He is in some island, some vacationing. So high availability, right? So I'm available, so he can take down time. And I have 4 customers with me here today. And this is not about me talking much. I will start it and hand it over to our dear customers because you want to listen from the horse's mouth. How and why they choose a technology, how they deploy, how they work it best for their environment. So key takeaways before we start, and we'll repeat them when we end it, is that with today's technology, SQL Server 2008 and SQL Server 2008 R2, it is possible to meet the HA and DR needs of highly demanding applications. You can upgrade from an older version of SQL Server to a newer version of SQL Server with downtime limited to a few minutes if you plan it well. If you work it well, you can do that with very minimal downtime. And you will see some examples of those going forward. And last but not the least, demanding HA and DR requirements where your SLAs are very strict. Technology is good, technology will take you further, but technology is not the end of it. You need good operational practices, you need skilled people, you need processes that ensure that you are not breaking things down that violate the practices that you set forward to start with. This is about my team that I just mentioned, SQL CAT team. And we work with customer in a program called Design Wins program. We'll love to work with you. If you have a project that you want to engage with us, come and speak to us at the end of presentation. Okay. As I mentioned, we spend a bulk of our time working with customer, and my specialty is the HA and DR area. And when we work with customer, we have found out that tier 1 mission critical high-end SLA requirement application, they do not just think about availability as an isolation. Availability is part of a bigger plan, and that plan is to protect against any kind of failure. Includes availability within a data center, includes availability across a data center. What if my entire data center is down? They prepare for situations like 9/11. They prepare for situations like what happened in Japan a few months back. They prepare for situations like if I have a flood, if I have an earthquake, if I have a volcano eruption. And when everything is put into place, so there is an HA and DR combined solution. And here are some of the 5 most frequently deployed, most successful HA and DR templates and design patterns that we have seen with most customers. And one of them is using failover clustering within a local data center for giving you local high availability, which is a shared storage solution. Most of you are all aware of it. And using database mirroring for DR, for protection against failure of an entire cluster or for protection failure against entire data center. We will have Service U and Care Group. We have 2 customers here today who will talk about it to you, how they deploy these technologies. One other solutions which is slightly different is using database mirroring as your local high availability solution and using log shipping to augment that high availability solution for DR purposes. And we have BWIN architectures to show you today how they use database mirroring and log shipping combined to give a HA and DR complete solution. You can also have a geo-cluster solution where one SQL Server failover cluster is spread across multiple sites. It's called a multi-site cluster. Some people like to call it a stretch cluster. Some people call it a multi-subnet cluster. It all means the same thing, that one SQL failover cluster stretched across multiple sites to give you HA as well as DR. And we have the EdgeNet solution to show you today, a speaker from EdgeNet to go through. We have seen customers using SQL Server failover clustering for local HA and using a SAN-based replication for DR purposes. An example is Progressive Insurance. We don't have the last two examples. We don't have anybody talking here today, but we'll be happy to take any questions from you on those architectures after the session is done. Any questions here, or I can move forward with each of these in detail? Okay, so without me talking much, I hand it over to David Smith.
Thank you. My name is David Smith. I am the Chief Technology Officer for ServiceU Corporation. We are a software as a service solution provider. We provide solutions for box office management, reserve seat ticketing, online registrations and payments. We have customers in all 50 states and in 15 countries, and as part of our transaction processing business, we are a level 1 PCI service provider. For those of you in the room that process credit cards online, you're familiar with PCI and some of the requirements. Some of that has also figured into our DR strategy that I'll talk about in a moment. In our case, as a SaaS provider, our DR scenario is if we are not up, we are not producing revenue. So we very literally can't afford any downtime at all. Now, our SLAs actually do allow us to have about 45 minutes of downtime per year, but our goal is 0 downtime. And we really work very hard to get as low as possible during the year. In terms of PCI, the requirements are that at your DR facility, if you have one, that before you go live with your DR facility, that all the security requirements have to be in place. That means that items such as scanning, security scanning that you have to do, the logging, all of that type of thing has to be done at the DR facility before you can go live. So in our case, what we've done is we've completely separated or made the two networks, they're connected, but made the two networks to where they're completely autonomous in terms of our PCI compliance. So all the security precautions that are in place at our main facility in Memphis are also in place at our DR facility, which is here in Atlanta. And that will figure in just a moment with a slide I'll show you. So our goal is to eliminate all single points of failure, and that involves network, it involves servers, data, and data centers. So our DR scenario for us is Memphis actually sits on an earthquake fault, and our DR scenario is Memphis just disappeared. Now what? So that gives us the data center redundancy. As Sanjay mentioned, we are one of the customers that is using clustering locally for high availability. And not only that, but we actually use clustering and database mirroring for not only high availability in our production environment, but we also use it in our development and test environments. For us, our strategy is we try to always have the same architecture in our development and test environments that we're going to use in production. There are a lot of companies that will have a single test server sitting on someone's desk and try all your code there, put it in production. We are very, very serious about doing all the things that Sanjay talked about, having all the procedures in place, doing all the testing, making sure that everything is always going to work like we expect. So we actually have clusters. They're virtual servers, but they're clusters in our test and development environment, and they're being mirrored to clusters at a remote environment that are also using database mirroring. We use asynchronous database mirroring because, in our case, we're mirroring between about 700 line miles. And there can be some network latency in between. There could be routing issues. So there are things that are beyond our control because we don't own both sides of that line. There is some equipment in between. And we want to make sure that performance is always high at our main facility. So our key goals in IT are performance, availability, and security. Those are the three things that we always ask ourselves questions about before we deploy any new technology. For database mirroring, if you're familiar with database mirroring, one of the ways that you can deploy database mirroring, and the typical way, is you take a full backup, you take at least one transaction log backup. On the remote side, you restore the database backup, you restore all of your transaction log backups, and then now that the data is in sync, you can start database mirroring, and it'll start shipping all the data. What we've learned with our experience is that that process works just fine, except that you have to be dependent upon a file copy, or you have to be dependent upon a hard drive arriving if you're shipping it to the remote facility and getting it restored, and how long does it take to restore, and I've got to keep logging in remotely. It may be the weekend, and I've got to see, has the file copy finished? Is it time to restore backups? Do I need to copy more transaction log backups? That affects my schedule, my life, my lifestyle. And what we've tried to do is put all the technologies in place so that the technology is not affecting our lifestyle. We can use the technology at our convenience. So when we start database mirroring, what we actually do is we initiate database mirroring by using log shipping. It works very well because I can say, start log shipping, perform a full database backup, restore it on the remote side, and then start shipping logs. I start the process, you can go through the wizard or script it, and I walk away. I go home, I enjoy my weekend, I do whatever I want. I can log in whenever I want, check it, see if it's synced, and if it is, now all my data is synced. I just disable log shipping, turn on database mirroring, and I've got database mirroring. That worked with my schedule instead of me having to work with a file copy and a Windows Server schedule. There is a case study, white paper, and it'll be listed in the deck that you can download, that actually talks in more detail about actually everything in our environment, what we do for high availability, including monitoring and logging and our entire infrastructure, if you're interested in looking at that. So this is a slide that's a high-level view of our architecture. You can see that the primary data center is in Memphis, the standby or the disaster recovery data center is here in Atlanta. If you look at the left side of the screen first, you can see that for any application, any given application, we come through a firewall, we've got the web farm, we've got another firewall, and then we've got our database cluster on the back end. Several things to notice here that are interesting. First of all, we have, for all of our Tier 1 applications, we have 3-node active, passive clusters. The reason that we've done that, first of all, for some of our PCI compliance, it makes sense to separate some of our data onto its own instance. But why have 2 nodes? Again, our goal is high availability, 0 downtime. So in our case, what we're saying is, if we have a 3-node active, passive cluster, and we lose 1 node because there's a hardware failure, and yes, we have critical contracts and we can get parts in quickly and everything, but if we have 1 node go down for any reason, we still have 2 nodes. I don't have to stay awake at night, I don't have to worry about it. My cluster is going to be up, and if there's a problem, it'll automatically fail over. So I have high availability even if I have a problem with one of my nodes. The other thing you see on there is DNS, and I would encourage everyone to use DNS as part of your solution. What I mean by that is our web farm, our application servers, are not connecting directly to the server itself. So if our server name were server 01, the connection string does not specify server 01. What we've done is we've created DNS aliases. The alias might be production server or production server 01, which points back to the actual server name. The benefit of that is that through the years, I can move around my SQL cluster, I can set up a temporary instance, I can do whatever I want, and all I have to do is change the DNS alias to point to a new server, and I've never changed my application servers. If you've ever had to go through an upgrade and you've had to change connection strings on application servers and hope you got it right, you probably know you made a mistake. And this eliminates that. It allows you a lot of flexibility, and again, in our case, we're looking at that as part of our high availability solution as well. So on the remote side, you see that we have the same typical infrastructure. We have asynchronous database mirroring between the 2 sites, but you'll notice that the web farm goes through the firewall and connects back to our Memphis facility. The reason for that is on an ongoing basis, we are always performing scans and tests against our DR facility. The DR facility, the databases there are, with database mirroring, they're always in a recovering or restoring state, so we can't query those databases directly. So what we do is we point the web farm at our DR facility always back to our production SQL servers so that we can always run queries and we can always test. And I know at any given time that hundreds of tests are being performed on an ongoing basis against our DR facility. Our DR facility will work. We don't have to fail over and then try to fix all the errors. It will work because we're testing on an ongoing basis. So in our case, we wanted to upgrade from SQL Server 2005 to SQL Server 2008. We were upgrading from Windows Server 2003 to Windows Server 2008. And we were also adding more disks and restructuring the SAN and the LUNs on the back end. So basically, we were touching the entire system. We were reformatting and restarting everything. But we have a problem because, as I said, our SLA permits us 45 minutes a year of downtime. So our goal was to actually accomplish this in 20 minutes or less. 20 minutes of downtime or less to upgrade from Server 2003 to 2008, upgrade to SQL Server, and completely redo the SAN. In actuality, our downtime for that upgrade was about 16 minutes. We were actually able to beat our goals. Here's how we did it. The first thing that we did is we set up a temporary Windows cluster with SQL Server 2008 and Windows Server 2008. We, at that point, had to remove database mirroring to the remote site because with SQL Server 2008, we can only have one mirror. So we directed that mirror towards the local temporary cluster. We had to remove our data center redundancy for a short period of time. And we set up database mirroring between our production cluster, production SQL Server instance, and the temporary cluster. At that point, we redirected with our firewall. We redirected everything to a down site. We did an extensive amount of testing within just a few minutes because we had already scripted all kinds of tests to make sure that we ran through everything that we needed to. We did unit tests, we did SQL tests, we did service tests. We ran through all of that and we said, are we ready to go live? Is everything working? Because at this point, we're mirroring from SQL Server 2005 to 2008. And we can't mirror back. We can't mirror back to an older technology. So this was our point where we said, is it good? Are we ready to go live? If not, we could have gone back to the SQL 2005 servers. We said yes, so we flipped the switch. We allowed our customers to come back in, and now they're hitting the temporary cluster. At that point, we rebuilt the old cluster. We completely restructured everything, blew it away, started from scratch. We actually had prepared ghost images and restored everything, and it was a pretty quick process. But we started from scratch. And then to move back, we established database mirroring from the temporary cluster back to the new cluster that we rebuilt. And then we did the same thing. We went down. We tested very briefly because we'd already done the major tests on the major upgrade. We've already upgraded at this point from SQL 2005 to 2008. That was the big issue. So we wanted to make sure everything worked fine, which it did. Now we ran through the same test, but we're not as concerned because we know everything is going to work okay. Fail over to the newly built cluster. And now we've gone live at our primary data center with about 10 minutes of downtime. Now, we still have a problem because we haven't established database mirroring to our DR facility. So we went through the last 3 steps for that. We did log shipping. We rebuilt the cluster on the far side with Server 2008, SQL Server 2008, rebuilt the SAN, did log shipping, established database mirroring, and now we're back up and live. The second time that we went down at the production facility, like I said, was about 6 minutes, so a total of 16 minutes to do a massive upgrade, which didn't affect users very much. All right, next I'm going to turn it over to Care Group. I've got time to take just a couple of questions real quick if you have them. The other thing I'll say is all of us are very passionate about what we do and the procedures we put in place. We'll stay around as long as you'd like to answer some questions. Okay, first over here, and then I'll get you. Okay, good question. The question is, do we ever shift to our DR facility to test it to make sure that everything is working correctly? We're able to alleviate some of those concerns by doing the ongoing tests that I talked about. We know that at least at the application layer, everything is working correctly. So that gives us a lot of confidence in the facility itself. But we do a yearly test where we fail over, move everything, which is very easy with the DNS aliases to just point things where we want them. Or if you're using the connection string and the failover partner, then it's just going to fail over automatically. So we do a yearly test to make sure that everything is up and running, because we don't want to be in a situation where we go down and it's hours or days before we're able to get back up. So we do consider that important, and we do a yearly test. Over here. Okay, great question. The question is, how do we resolve the DNS issue in regards to instance names? We actually were not able to solve that because we're not using default instances. We're installing it with an instance name. But what we do is we just keep the instance name the same between the two sites. So any application, the instance name is always going to be the same between our primary data facility and our DR facility. If you haven't worked with that, what that means is the server name in the connection string is actually the DNS alias, but then it's / instance name. Okay, I'll take one more in the back. Okay, the question is, are we using, I mentioned that we were using virtualization. In our case, we're using virtualization in our development and test environments. We're not using it in our production environment just because we do very high transaction volume. We're looking always to gain 3 or 5% on our overall throughput, and we don't want to lose anything at all from virtualization. We do use it extensively, and we do it for a lot of testing and throughput testing in our development and test environments, but only in those environments today. In our case, we're using Hyper-V, and the reason that we're using Hyper-V is our decision has been, in any case that we can, to stay with a single vendor. Because if we do ever have a problem, then we can go to that vendor and say, we have got to do this. This is a mission critical application. We've got to get it solved. There's never any finger pointing with whatever companies. So even, for example, if we use an EMC SAN, we're purchasing that through Dell because we're purchasing our hardware equipment through Dell. And that just allows us a single point of contact and a single resolution. All right, we'll take some more questions at the end. Right now, I'm going to go ahead and turn it over to Ayad, and he's going to talk to you about the implementation at Care Group.
I got the clicker. Okay, hi everybody. My name is Ayad Shammout. I'm Senior DB Consultant. Today I'm going to share with you about Care Group, how they implemented HADR implementation for SQL Server. And Care Group is a group of 4 hospitals in Boston, located in Boston area, about 16,000 employees, 146 mission critical application. Some of them has a patient, it's a patient care system, has a direct impact on patient lives. So this is very mission critical application with a back-end SQL Server databases. About 2 million patient medical records stored in SQL Server. Annual revenue about $2 billion. HADR requirements, almost 0 downtime. The RTO, RPO is 0, so no data loss and almost 0 downtime. All our mission critical running on SQL are clustered and mirrored as well. Care Group environment, actually, they have, first of all, we group the databases based on their SLA. So mission critical application or databases are AAA, means 0 downtime, 0 data loss. AA, it's still 24/7, but with 1 hour almost data loss and downtime. And 1A is less critical. So that will allow us to maximize the investment of SQL Server implementation and focus on the AAA versus AA or 1A application. So this is a HADR design implemented at Care Group. So as you see on the diagram, we have the main data center with a clustered SQL Server, and the DR site also clustered as well, with database mirroring in between. We run a test on those applications, SharePoint, reporting services, BlackBerry, Citrix, VMware. And the way it works, actually, as David mentioned, we highly recommend using aliases. And you can see now in our implementation how the alias was seamless to the application, so we don't have to worry about connection changes. So we have the server. The connection string is green as an alias, \SQL1 is the named instance. So the user will trying to find green. Sorry, it's not animated. Okay, it's a different slide then. So actually, in order to automate the whole failover process from the main data center to the DR side, we deployed and used the, it's a device, it's a network device by Cisco called Global Site Selector, GSS. With the GSS, what it does actually, it will help you identify the connection server name, the alias, with multiple IPs. So in this case, I have two IPs, one of them active at any time, the other IP is passive. So that device, the GSS, will keep pinging the primary active server, production server. As long as it's available and replied, then no problem. As soon as we lose the connection to that server, it will switch the IP address, which point to the DR side. So in case of a disaster, right now my connection is point to the DR. Now GSS will detect the failure, will change the IP, deactivate the first one, activate the second one, and automatically all the user will be redirected to the DR servers on the right side of the screen. And again, with the mirroring in between, we do the manual mirror switch because of the clustering and mirroring. You can't automate the whole. You can, but in that case, you can control the priority of the failovers. Does it fail first to the cluster or first to the mirror? So we have the automated failover to the cluster, but we manually fail over to the mirrored server. So this is one scenario, one design, how you can implement HADR, a combination of clustering and mirroring in between. Another actually experience and lessons learned, also best practices. Sometimes you might have an existing new hardware, but you'd like to upgrade the hardware from 2003 to 2008. In the same time, you want to upgrade from 2005, SQL 2005 to 2008. But you don't have a budget enough to buy a whole new hardware in order to do a complete migration. One thing you can do, and this is implemented, is we build a new cluster environment with Windows 2008, and SQL 2008 R2. We borrowed two servers from the server team and build them with a new operating system and SQL Server 2008. And then establish mirroring between the first two nodes on the cluster and the old cluster with the new two nodes and the new cluster. Replicated all the database over. And after that, we just broke the mirror and we do the DNS change. So all the connection now pointing to the new servers on the right side, which are 2008 Windows and 2008 SQL. Once we're done, we remove that. We took those two servers, evict them from the old cluster, and rebuild them again and reintroduce them to the new cluster. Now I move the two nodes from the left, move them to the new environment with Windows 2008, SQL 2008, build mirroring in between, replicating all the databases over. Again, we'll do a DNS change, so all the application users connecting to the new two servers, remove the mirroring, do the same thing, evict those two nodes, rebuild them, and bring them again over in the cluster. So now I'm back to the 6-node cluster, same hardware, reuse them with the new operating system and a new SQL Server release. So last thing, again, we do the mirroring, break the mirror, and then once we're done, those two servers evicted, give them back to the server team. So in that case, we utilize the existing hardware without buying additional servers or storage, and we fully upgraded the environment from 2003, 2005 to Windows 2008 to SQL 2008. And doing so, the whole downtime was a few seconds, actually. One application about 30 seconds outage while we're doing the failover from the old servers before we broke the mirror, and the DNS change took in effect immediately. So that kind of an experience, you can utilize database mirroring for even database migrations. If you're going from 2005 to 2008 one direction, it will minimize your outage, and you bring all your application, maintaining the same server connection. All the application doesn't know that you just upgraded the backend databases from older release to the latest release. And that's it for me. A question? We use the SQL 2005, 2008 database mirroring. What technology we use for mirroring? Yeah, it's a SQL database mirroring. Yeah, the question is about where's the global site selector sits in the data center. Actually, we have one in each site, one in data center, one in the DR site, replicated real time. Because again, for redundancy, we rely on the GSS. If that goes down, nobody can connect and knows what's the IP address. Sorry, I couldn't hear you.
When you first upgraded those first two servers to 2008, right, and then you cut the mirroring, were you still taking traffic to the other two 2003 server farms?
Did you hear the question?
Can you hear me?
It's not like, if you speak up.
Yeah. When you first upgraded over to the two 2008 servers,
Yeah.
right, were you still taking traffic after you cut mirroring to the old servers as well?
Right. No, actually, yeah, once we build the new servers and we set up mirroring, after that we do the switch over, so the mirroring the two new servers become the primary or the principal databases. The DNS will take an effect, so all the traffic will go through the new servers. Then we can remove the old servers.
Okay, so the old ones were just backup at that point.
Yeah, we leave them as a backup, make sure everything is up and running, all the application, no complaints. Then we can evict those two nodes, rebuild them second day, not the same night. Rebuild them and redeploy them again in the new environment.
Okay, thank you.
You're welcome. Well, all the SSIS packages, the question is about SSIS packages that was implemented through the implementation here. All the SSIS packages actually, it's outside of these boxes, but maintaining the same connection, using the alias, nothing changed on the SSIS package, run the same night, no problem. One last question. Okay, so I turn that to Thomas.
Need the clicker. Okay, my name is Thomas Großer. I worked for bwin for about almost 6 years. I'm now with a new company, but I'm still presenting this because it's the solution I created. bwin is an online gambling site. They do sports betting, poker, casino, everything you find in Vegas, you find on their website. They are big, they merged with another company, they're even bigger now. So their requirements for performance and for high availability are really, really high. So the mission and the challenges I had to solve was failure is not an option. If your bank goes offline and loses your money, that's accepted now. Yeah? If an online gaming site does the same, they are in big trouble. So at bwin, we defined a very large database, that any database that actually needed attention from the DBAs. We were running thousands of databases, but only a few of them actually needed attention. And believe me, it's not just size. Just because it's big doesn't mean it needs attention. The hardest database we actually had was just 200 megabytes in size. It's not easy to handle. One of the first things I learned in my career over the years is you need a service level agreement with your management, because otherwise you're working blind. At bwin, it was very simple, 3 things. 100% transactional consistency, 0 data loss, and a lot of availability on the database so that the application servers could screw up. And we had an assumed worst case scenario, because if you don't know what you're protecting against, yeah, at some point you must stop. Because, you can protect against a single failure, dual failure. In this case, we protected against the full failure of a data center. So if a data center is gone immediately, like within a second, it disappears, that's the worst thing we protect against. We didn't protect against anything like a continent goes down. Yeah? Some people do. Yeah? If you start protecting against the planet goes down, I think you're overdoing it. So let's have a look what kind of system we came up with. First is we tried to standardize everything. So the smallest server was handled like the huge big boxes that were running the production databases. So we tried to keep the names the same, the way we lay out the things on disks, everything, keep it in a standard way so that for the DBA it mustn't make any difference if it's working on a small server or on a large server. Because believe me, at 3 a.m. in the morning, if you're not familiar with the servers, you really screw up. So the next one, work by the book. We tried to document anything. I know nobody likes to write documentation, but again, 3, 4, 5 a.m. in the morning, it helps. And of course, you need some really clever guys around if the book ever runs out of pages and you have no idea what's going on. Yeah, so always have the numbers of the CAT team guys ready. You need them. Okay, a little bit of the overview. How about how the environment at Bwin looks like? They have about 5 DBAs. The one database engineer was me, so that's gone. They had 100 plus SQL Server instances on about the same amount of servers. So they were running mostly one SQL Server on one hardware. 120 terabytes of data in about 1,400 databases. They were using about 1.6 terabyte of raw storage to store these 120 terabytes. So for 0 data loss, you need a lot of copies of your data. 5 terabytes of RAM, and the largest single instance, single server, single instance, single database, did about 450,000 SQL statements per second. And altogether about 500 billion database transactions per day over all databases on all servers. So a pretty usual average busy site. So let's look at the solution. Sorry, the last presentation where we gave the background was white, and they changed it to blue, so the server icons look a little bit iffy. We did the solution with database mirroring. Why not start with clustering? Performance reasons. We actually hit limits that we needed a very, very low latency in the transaction log files. And if we're doing shared systems, we couldn't get the latency down to something that we actually could live with. So we couldn't use clustering for performance reasons. Principal server was mirrored in with synchronous database mirroring to a second data center. The data centers were only about 11 miles apart, and there's dark fiber between them, and there were 10 gigabit Ethernet lines just for the mirroring and everything. So a nice setup. Usually the mirroring only added about 1 millisecond per transaction. If we did it with SAN replication and clustering and all that stuff, it was usually 8, 9, 10 milliseconds that get added to each transaction. So actually database mirroring helped with the performance. And then we also kept 2 additional log shipping copies around. So we log shipped to one server all the time. As soon as a backup, log file backup was ready, we applied it. We tried to do as many log backups as possible. And another one where we deliberately delayed the restore by about an hour. The reason for that is most errors are not hardware, storage, it's humans. So the delete without the where on the big table, the drop table in the production instead of testing, stuff like this, it happens. People make mistakes. And here we had a restore that was almost before the incident. So in case of something really happened, really bad happened, we had a logical copy that was about an hour behind. So it was so if actually someone dropped the table, we would restore the couple of minutes on this server till the moment before the drop, copy all the data back to the production, and this was the protection against human error. Synchronous mirror helped us for all kinds of, okay, data center goes down, server goes down, storage is corrupt, anything like this. And the second log shipping was, in case of one of the others fails, we immediately moved the mirroring to the second log shipping so that we could have a synchronous mirror again and not lose data by losing another server. Yeah, we did a lot of backups. every Monday, Wednesday, Friday, Sunday, one data center, the other days, the other data center. So we try to keep the backups on 2 different sites, and the log backups actually got backupped to both data centers at the same time. Another little thing is we needed to make the things fast. So I already mentioned we went with direct attached storage on the solutions to get the latest microseconds out of latency. When we started the solution, there was no x64, really, because we already were doing stuff like this on SQL 2000 without the mirroring. Back then it was just log shipping. But everything was on Itanium. They were really big boxes. So each NUMA node, that's a building block within the servers, was back then 4 dual-core CPUs. On the new x64, it's now 8 to 10 cores, depending on if the server is like 3 months old or only 2 months old. We didn't increase the amount of RAM per server that much. The network was changed. Back in the Itanium phase, it was still 8 times 1 gigabyte. Now it's just 10 gig cards. Makes it much easier to connect. Also, we're still using some SAN-based storage, but only for the data files, not for the transaction log files where we really needed the latency. So we had 4 times 4 gigabit, and now it's just 1 times 8 gigabit. And back then, 2 RAID controllers were used for the local direct attached storage for the log file. And now it's one of the nice little solid-state devices that do a lot of magic. And the trick how to get these systems fast was, in the Itanium time, we used 1, 2, 4, or 8 of these NUMA building blocks in one server. And with the new servers, it's at least 4 or 8. So at the end, the machines are pretty much the same. CPUs and RAM got faster, so that's how they're keeping up with the increasing volume. Some of the machines, the picture I showed you before was 0 data loss is the highest priority. So if something would happen, the DBAs would make sure that everything is up and running somehow closely before you go back online. That hurts your availability. So DBAs, only people with light sleep, you can wake them up quickly. But we also had solutions where availability was more important, and eventual data loss was possible. And in these cases, we also added a database mirroring witness, which in case of a failure of the principal would pull the solution into the second data center. Yeah, that's the solution. I open the floor for a couple of questions. I think we're still good in time. Yeah. The question is how many mirror pairs we handle per server. The really big ones, there was 1 database on it, so it was 1 bear. Some of them, I say at least 20 to 30 easily. I know at the beginning Microsoft was giving out like don't do more than 10, but that was like in 2005 where systems were slow. They increased a little bit on speed, so I would say 30 to 50 is no problem today to do that. Okay? Yeah. Yeah, one in the back. In my second example, when availability was the higher priority over 0 data loss, we added a witness. That's the little guy above the pink box that takes a witness. The perfect place for a witness is a third data center. Yeah? I do not disagree with that. Unfortunately, there were only 2, so we had to put it in one of them. Yeah? Bwin uses to monitor the system center operations manager. There's a lot of custom scripting that actually generates. We had an agreement with the SCOM team. We named our jobs properly, our SQL agent jobs. So like it started with a #warn, #alert, #leave me alone, depending on what you need. And Mom picked it up. So whenever an agent job failed or so, Mom picked it up and forwarded it to the right person. Yeah, but let me put it this way: the how they call them, the management packs for SQL Server needed a lot of tuning before they were like no more false positives in. Yeah, so I wouldn't say they are really but they need a lot of tuning, especially if you're in a very environment that's not normal, that's not average. Yeah? One of the things I really like about it, it warned me immediately, you have too many connections. And I looked at the system and was like, yeah, that's 2,500, that's normal. Yeah. So, more questions? Over here? The failover, the principal idea behind the failover was whenever there's a new page, we apply it on the mirror systems, on the secondary systems, and as soon as we have some sort of problem, we fail over. So I would say at least 3, 4, 5 times a year there was a failover from one. Both data center had the same equipment, so we didn't care where it was running. So if it just reversed, it didn't matter. So it was running either here or there, a couple of times a year. Some systems more often, depending also how many times they had rollouts or changes. Yeah, but it was tested, yes, all the time. You have to. You cannot pray for disaster recovery. Next question? Okay, I don't see any hands over, so up to EdgeNet and Mike.
Hi, I'm Michael Steinecke. I'm VP of Information Technology for EdgeNet. We're a leader in data services, guided selling, and marketing solutions. We provide services to businesses and retailers like data collection and rich product data for selling solutions. We collect, certify, and distribute product data to companies like Google for search and shopping, for Bing search, and to multiple retailers. We're also one of 4 certified and active US GDSN data pools. And we go through rigorous certification and data quality scoring processes with the data that we collect. Our solution is a distance cluster solution. The application itself utilizes multiple SQL Server instances, so we need support for Microsoft Distributed Transaction Coordinator, something that with mirroring databases you can't support. So our only option for our application was clustering, and to have both high availability and disaster recovery, we chose distance clustering as that solution. The hardware for our implementation is SQL Server 2008 R2 Enterprise, Windows Server 2008 R2 Data Center. We're running an EMC SAN, and with distance clustering, you need some type of hardware or software solution to replicate your data between your data centers. The solution we've chosen is from EMC. It's called RecoverPoint CE, and that's a SAN-based replication. So it does all the replication on your SAN and not on your SQL Server hosts. We have a multiple two-node stretch clusters. Our primary data center is in Milwaukee. Our disaster recovery site is just a few miles from here in Atlanta, as Service Use is as well. We have 4 clustered SQL instances on this one pair of systems, and 1 clustered MSDTC. In that system, we're replicating about 8 terabytes of usable disk on 54 LUNs. One of the tips you want to look at when doing a distance cluster is what is that latency between your nodes. As the other gentleman mentioned with their secondary data centers, they're very close together and have low latency, or if they're very far apart, you have to do things like asynchronous commits. With the distance clustering solution, that latency is going to affect how much data has been replicated from your primary site to your disaster recovery center. The solutions like RecoverPoint are transactionally consistent in their replication, so whatever point in time they've replicated the data to your secondary site is where the system will be if you'd have a failure at your primary data center. One other thing to keep in mind with that latency is when you're doing upgrades to allow to do service packs or CU installs on your SQL servers, the nodes interrogate each other when you're running those service packs, and that network latency between those data centers greatly affects the time it takes to do those processes. So when you install one of these from the start, you want to make sure you do a slipstreamed installation of SQL Server to get you at the level you want. Otherwise, just setting the solution up the original time will take you quite a bit of time to apply all the SPs and CUs on both sides. So a little diagram of what the system looks like. On the left side, we have the Milwaukee data center. On the right side, we have the Atlanta data center. Our primary node is our Milwaukee data center, and it is attached to an EMC Clarion CX480 for its disk, and then has the recover point appliances on the bottom, which are also attached to the disk. Between data centers, we have a 300 megabyte Ethernet connection, and this is a stretched VLAN. So with SQL Server 2008 R2 and prior, you have to be on the same VLAN for your cluster nodes for SQL Server to work. So that's a stretched VLAN across those two data centers. On the right is a mirror of the exact same hardware on the left. So we can fail between any one or all instances between Milwaukee and Atlanta whenever we like. Typically, during load, our system is no more than about 30 seconds out of synchronization from one side to another, and that's under heavy load. Most of the time, the system is within about 3 to 4 seconds out of sync. This screen here is showing the dashboard for Recover Point CE, and it's showing some of the monitoring within CE, showing bandwidth reduction across the wire. The product does quite a bit of compression, even in the lowest setting. So even on a connection that you'd have between data centers that isn't 300 meg, even if you had a couple of T1s or even a T1, if your transaction load isn't too high, it can handle replicating that data. That's it for our solution. Any questions? Go ahead. If you're doing a solution now that requires DTC, you will still need DTC and Denali, because that's what's marshaling the transactions between the instances. One thing I should also probably mention, as opposed to the different solutions with DNS problems or addressing those between different sites, because our sites are in one cluster, each instance has a unique cluster name, and that virtual network name is the same no matter which is the owning node, whether it's the Milwaukee node or the Atlanta node. So our applications will connect to either one of those servers seamlessly. So for testing, we can fail the node to Atlanta, and our app tier in Milwaukee can connect to it, or our app tier in Atlanta can connect to it. It doesn't matter.
Did you have a question on the stretch VLAN? Did you ask about the stretch VLAN in the GeoCluster solution? Correct. Denali will eliminate the need for a stretch VLAN.
It doesn't eliminate the need for doing some other type of replication for your disk, though. Another question over here? Mm-hmm. So the clustering for MSDTC, you can actually create multiple MSDTCs in your cluster. So depending on what the load is you have on it, you may choose to have multiple of them. So you could have more per cluster node if you'd like. It depends on what your configuration is and whether you want to have that or not. But that DTC resource is going to marshal the inter-instance transactions. So you want to have that DTC object owned by the same cluster node that's owning the majority of the instances. In the back? Have I tested a what? Network link failure. Yes, we have tested network link failure, and that's a great question. In the normal configuration, we are in a majority node set cluster configuration, so we have a file share witness that resides at our primary data center. So if we lose network connection between Milwaukee and Atlanta, the Milwaukee side stays running because it has quorum with that majority node set. If we lose an entire data center, we have to take the Atlanta data center and do a forced cluster start to get the system to run on the DR system if we were to lose the entire data center. I'm sorry? Go ahead. You force quorum start on your cluster. It doesn't. If you lose the data center, it won't automatically start. You have to force quorum and manually start the cluster on the DR side. And then once you do that, if it was an extended down period, if for some reason the whole data center has been wiped out by a natural disaster or something like that, you would create another server over there or another file share witness and change that node and point it at that so it wouldn't have to stay running in a forced quorum configuration. And like Thomas mentioned earlier, if you have a third data center to put that voting node for quorum, that's the best solution. But like most, a third data center just for that for that majority node set or that voting quorum member is an expensive option. Anyone else back here? Who wants to start? I guess I can start with the mic. So in our configuration, you patch the passive node first, fail, and then patch the active node. So for the clustered solution, it's pretty straightforward. You have just the time it takes to do the failure as your downtime.
Yeah. For the is this on the non? Can you hear me? Okay, at Bwin, patching is the secondary systems. As soon as a patch is available, it's applied. So all non-running systems are always perfectly patched. And for the running systems, there's a system. There's a sheet where you put in your requests for downtime. And there's two columns. One, I need it really, and I'm causing the downtime. And the other one is, if someone else needs downtime, I piggyback on it. Second one is very long all the time, and at some point someone has to put something in the first one, and that's the guilty guy who ruined the availability. And then everybody else piggybacks on it. It's pretty good because it's just not creating this, I need to apply every patch every day. There are patches you should apply immediately, like everything that has to do with security. Yeah? If there's a hole, you have to apply it. Yeah? And then, it costs you availability. But again, you patch the secondary systems first. That's the same on clusters, on mirroring. You fail over, and you're fine, and then you patch the new passive system. I think that's the same for the most of our solutions. It happens exactly the same than if your SAN storage fails. You have a problem. You fail over to the secondary mirror node and run from there and fix the problem. It's the same kind of disks. It's just the latency is lower. Direct attached storage is the same quality, the same thing as SAN-based storage. Sorry, it is the case. I know that the SAN manufacturers, I hope they are in the room and hear me, put a lot of money in their marketing to make you believe different, but actually it's not. Okay.
For the gentleman from ServiceU Corp, can you describe the process you went through to test your migration process when you went from 2000, you did the big migration from 2003 to Server 2008 and SQL migration as well, to the point where you were comfortable pulling the trigger and saying, yep, we're ready to actually do this process for real?
Okay, so the question is, what did we do essentially to assure that we were comfortable going live from Server 2003 to 2008 and SQL 2005 to 2008? Part of our solution is that we have ongoing monitoring that happens all the time. And like I said, there's hundreds of checks that take place. We're actually performing test transactions that actually hit our processor. We're performing DTC transactions in some cases. We're hitting all of our different systems. We're actually reserving tickets. All the things, anytime that we've ever had a problem, what we've done is we've said, if we have a problem once, that's understandable. If we have it the second time, that's our fault. So anytime we ever have a problem, we say, what check can we put in place to make sure that this never happens again? So we already have a huge database, if you will. They're not actually in a database, but of problem issues. So we've got those that as soon as we want to go live with a new version or we want to test some new code, new software, new system, we can run through those tests. But for this upgrade, in addition to that, we created specific tests that we knew were things that were different between 2005 and 2008. We ran through, we checked performance, specific performance counters that we measured before and after. We had numerous tests. We sat down in a room and we said, okay, what are all the things we need to test? We scripted it all out. We ran those tests beforehand. We made sure all that was working. And then we ran it when we were down for that temporary 6 or 10 minutes. So there were numerous tests at numerous layers, not only SQL scripts, but also unit tests that we performed on web and application servers and that type of thing. So it was pretty extensive, but it was pretty fast running that across a whole web farm to come back and say, hey, everything passed, or we had one little issue, we fixed that, run the tests again, we're good to go.
Do you also take backups in your whole scenario, or you're considering the database mirroring instances as your backup?
Okay, it's a little hard to hear.
Do you also take backups of your systems, or you are considering like your DR and mirroring databases as your backup?
Okay, I think we'll have some different answers up here. In terms of Service U and database mirroring, we can't today, with SQL Server 2008, do a backup on the mirror. So we do consider the fact that the data is there to be our backup. Now, like I said, we try to eliminate single points of failure. We also have tape backups that happen every night at our facility in Memphis. We have a contract with a service provider that stores those tapes off-site in the vault, who has a contract with both emergency management agencies and some helicopters so they can get access in a situation with an emergency. A lot of times the airspace has been locked down. They have contracts in place. They will fly our tapes out to the first available airport, and they will FedEx those tapes to our facility here in Atlanta. So we have multiple plans if there is ever a need for a backup.
One major thing is any kind of high availability solution, mirroring, clustering, whatever, doesn't relieve you from backups. Backups are for the worst case scenario, especially something killed your database. Everything else you do is just helping you to get to a restored and failover state quicker. Yeah? But you have to have backups, multiple of them. You have to restore them in a frequent base, like every time, and test if they actually work. And you should then run some checks on the database on the restored one. One very little trick we used to do all the data warehouse loads by restoring the last backup to the data warehouse, and then let the bin counters check the data every day. So they worked for us, not the other way around, it's usually.
So you should not only have a backup strategy, you should also have a restore strategy. A backup strategy without a restore strategy is void or blank. Thanks.
So in our GeoCluster solution, we do backups at the primary site, and with the hardware replication solution, it uses a journal volume on the DR side. So we have a full copy of the data there. We also have the ability to roll back in time. If there was some data corruption, we could roll back in time and bring that database up very quickly. So we are using the backup purely for a complete disaster type scenario.
I know there are a lot of questions, but some people are trying to leave. We will be here as long as you want. We still have 10 minutes in the session, so I request people who can stay, will stay. For the sake of the session, there are a lot of slides, and there is slides indicating or redirecting you links to a lot of useful resources, detailed case studies about each of these customer deployment scenarios. You'll find here a lot of best practices that we have produced working with these customers as well as other customers. You'll find them here. You'll find them useful. And we are answering questions. We'll do that. Do your evaluation And if you like this session, you give us a good grade so that we can be here next year again with these customers. So please continue. Please, this is about the panel. So the more questions you ask them, the best.
I just actually have one comment on the question about, actually an address the question about the instance and the alias instance name. You can do that actually without using the named instance. You can pass the server name, comma, the port number, the TCP port. In that case, you can alias just the server, but you always need to use the TCP port in your connection string. In that case, you don't worry about if it's SQL /SQL1 on main data center, maybe /SQL11 on the DR. As long as the first part is aliased with the same TCP port on both sides, you should be able to do so.
And to add to that, if you add multiple IP addresses to your servers, one for each instance, and are okay with running SQL Server on the default port of 1433, you can give a name to each IP address and then not have to use an instance name or a port at all.
Evaluate different technologies, and the reason we went with the clustering, database mirroring, because those two technologies are under the DBA control. If you want to go with that additional different technology, network-based replication, you have to get the server team, network team involved. So in a case of a disaster, you may not get everybody. So it's always simplify your
These resources were focused just on this. Their entire job was in this DBA. Yeah. Yeah. They had to work 24/7, so at least one of them was on standby duty all the time. They work in Austria, so the labor laws are very pro for the worker. So everybody has 4 weeks of vacation, can be a long time sick, so you have to take this in account. Usually it's impossible to do 24/7 with less than 5 people in Austria, so that's a reason to have them, and you need them. At 1,400 databases, there's always someone who wants a rollout. Bwin runs a rollout schedule, like every day new versions of anything comes out there. I mean, each product itself has a like 3, 4, 5 week release cycle, but I have like 400 different products, so there's a lot going on. So they were not sitting around and waiting for disasters. They were busy all the time. Yeah, and I want to say is most of us are hanging around after this session in the Technical Learning Center in the Expo Hall and either in the cluster or in the SQL Mission Critical area. So if you have thought about questions in the next days, just come by and we'll try to answer them then, if you don't cancel up there. SQL Server cannot run in active-active. It's the mirror and...
So one of the architectures that we have shown there was using a peer-to-peer replication between 2 data centers. Was an example of a travel industry where they have multiple data centers, one in Asia, one in Europe, one in the US, and they do peer-to-peer replication between all these sites with an assumption that only the local site will change the local data, but it will be replicated to the other site asynchronously, almost as much as it can keep up. In case one of the sites goes down, the application can use the data from the other site. So that's the model of using active-active. We have a white paper published in SQLcat.com, and if you need more, please get in touch. These customers are in the SQL Server TAP Technology Adoption Program, so they have access to the early bits. They've been evaluating for almost a year now and giving us continuous feedback. So,
yeah, Yes, for Bwin, they're working very close with Denali and testing everything. And if you remember my four servers with the mirroring and the log shipping, in Denali, it's going to be 2 synchronous mirrors and 1 async mirror with the applied 1 hour delay. So that's basically Denali Lite. So it's prepared for it, the hardware is ready. So I'm guessing they're going to upgrade very quickly as soon as it's there for all the other benefits. Yeah, it's architectured in this solution. Yeah.
So for our distance cluster solution, we're definitely going to be doing Denali and switching to not have the stretch VLAN. We have some applications that don't have the DTC requirement, and on those we're definitely thinking about doing the replicas and mirrors. And we're also going to be mixing the two different pieces of always on in Denali. So we'll have the distance cluster and then also a read-only mirror locally that's synchronous to be able to do backups and also offload work to that local read-only copy.
Yeah, we are evaluating Denali as well, and that will be replacing the current design with the cluster and mirroring and using always-on feature, where we have multiple secondaries, and one of them could be up to 2. You can have readable copies, so you can offload your backup of the no active database and run them in a DR.
What process kept you awake at night? What process kept you awake at night while designing this solution?
The question was, what process kept you awake at night?
Today, nothing, just my wife.
I mean, which is the most critical part in designing this solution you found that?
Well, actually, we were able to do most of this, even patching nowadays, we do it early after hours. We used to be, a few years ago, we used to do a lot of work after midnight because of most of mission critical application. Now with the clustering, mirroring, we've been doing patching, even upgrade. Last time we did the upgrade in the middle of the day without impacting anybody. So we'll give you a lot of flexibility.
For me, the hardest part that kept me alive is not the technology. Technology is actually really easy. It's more the process and the politics inside a large corporation, how to sell it to all the other departments. Yeah? It's sometimes really hard. I mean, if you're too harsh, they'll start blocking. If you're too easy on them, they just ignore you. You have to find the middle ground, and that's really the hard part. Yeah?
There it came. I would add one thing to that. For me, what keeps me up at night is lack of knowledge. So all the monitoring, the alerting, everything that we have, and having the right people on the team, knowing that things are getting handled right away, that's critical for us.
No, it's in pairs actually. For redundancy, you want to have them in pairs.
Absolutely. I was just remembering your picture. I thought I only saw one.
Yeah. Well, the other thing, if you don't have GSS, you can accomplish the same thing with DNS, but it's going to be a manual change. It's not automatic failover.
Yeah, so earlier you talked about the importance of not only having a backup process, but a restore process. How often do you guys get to test the restores? Do you actually have a schedule in place?
At Bwin, each and every backup gets restored on the next day, and DBC check DB on the day after that, and then it gets thrown away and just runs in circles. They're backing up in one data center on the even days and the other on the odd days. If the backup server is not doing backups, he's doing verifies. So yes, in my opinion, I wrote a white paper about it. It's on the SQL CAD side. If a backup is not verified, it's not restored and DBC check DB, it's not a backup. It's a bunch of data that might work. Yeah?
You're saying bean counters, people are actually doing this, or you have like automated?
No. For most of the databases, it's just the backup is written to disk. There's a huge disk in there that's used to restore the database actually on the backup server, one after the other. As soon as the restore is complete, a DBC check DB is issued. The whole database is checked for any consistency problems or whatever. So this usually should give you, okay, I can restore and use it. the remark I was giving for the data warehouse load. A lot of databases are backup restored onto the data warehouse and are used to load or fill the ETL process into the data warehouse. And then the people who actually consume all these reports, they check them if they have any sanity in it. And one day we actually caught a flipped bit because someone didn't believe us that we made a couple of $1 trillion last night. Yeah. And it was a missing service pack on Windows. It was way back in Windows 2000 times that actually caused SQL Server to flip a bit back then. It's not happening now, but back then in the early days happened. Yeah.
So you do your check and delete DB system. You do that on the restore test, so you don't never do that on your actual
No, it doesn't relieve you from doing it on the production. It's just one way to actually check everything in your database, and it's easier. You could do, if you know your data, you could do more intelligent tests on it. If you like, you know, in this column it can only have values from 3 to 11, you could actually write tests to check that. But DBZ CheckDB, it hits every page that has content on it and reads it once and makes checksums. And you can ask Paul Randall if he's around what DBZ CheckDB is actually doing. From time to time, you have to do it in production. It's really hard if you're running real full power all 24/7. But if there's the slightest idea of something's wrong, usually if the backup is clean, you know you don't have logical errors on the main database. There could be something physical in there that you're not seeing on the backup, but usually it's a very good indicator you're good already. Better than never doing it. Question back there. The question is, oops, say it again. The question is who actually declares what's a disaster recovery, what's a disaster when it starts, and what are the service level agreements. Yeah. In my case, it was about 3 years of negotiating with management. It was like baby steps at the beginning, like trying to get the information, what is important for them. Yeah. Sometimes they have absolutely no clue what technical people are talking about. You really have to learn to speak manager and giving them it in real examples. Okay, if we don't do that, it will gonna cost you that much. And here's, hopefully Gartner has some statistics on it, then it's usually easier. But if you have to create your own, it's not easy to get to the point. Best is, you think what you would do, write it down, and just let them agree. Yeah? So you dictate the terms, and you can usually come up with something much more useful than if it's just from the bottom down. So usually at the companies I work for, the management appreciates if you give them a sane and doable thing. Is, yeah, if you come up, you need $3 trillion to implement it, they're not going to fly for it. Yeah, but if you make useful example, okay, if you lose this data, if this happens, and always use other companies that actually were unfortunate and run into something. That's also very helpful. Especially if it's direct competition.
Sorry, Thomas,
yeah.
that you're done. In our case, you're asking who actually declares a disaster, who has to move the facility, who makes the decision that we're now live in Atlanta in our case instead of Memphis. In our case, what we've done is we have several key employees that are empowered to make that decision that have satellite phones. We assume that we've had an earthquake in Memphis, we have no communications, we have no internet access. So we have employees that live outside of Memphis, actually employees in Atlanta in this case. And we say, okay, we will call and let you know that you need to go through the DR steps. And we have things scripted, we have steps, we have a whole process already in place. You don't have to think, you just have to follow the steps. If you don't hear from us, you will know. Alerts are going to be going off. People are going to know, hey, there's a major problem. They're going to see on the news, hey, something just happened. It's going to be pretty apparent very quickly something happened to Memphis. If you do not hear from us within a certain amount of time period, with a certain amount of time, assume that we're dead or that we're not going to be able to contact you in any reasonable amount of time and go ahead and fail over. So we actually have those parameters set up beforehand.
I just wanted to know if anybody took advantage of file groups for partial availability in their cluster or database mirroring solutions.
Yeah, we have databases with file groups, and in case of mirroring, one thing is actually from best practice, you want to make sure the drive letters, that the folder, the installation path on both the primary or the principal database and the mirror are identical, exactly the same. Otherwise, you might get an error message. So if I have my data file sits on E colon / data on my active or my primary side, it has to be the same path, especially if you want to manage or create file groups while the database is online. Does that answer your question?
So we have customers who take advantage of file groups, and file groups can give you partial database availability if you back up and restore them in the right order. And those scenarios where it works best, where you can have at least a partial of application up and running if some of the file groups are up and running. In some cases, unless your all database is up and running, your application cannot come up and running. There you are not taking advantage of partial availability. So if you have designed your system such that you can have some file groups up and running plus your primary file group, in that way you can really take advantage of that. We have published a white paper on this on SQLcat.com. I urge you to go through that and follow. Right.
The new company I work for now is using that. So, but I can talk about it in more detail here. Come to the booth and we can talk.
Any more questions? Thank you. We will stick around here if you need us, and we'll be in the booth, either in the mission critical booth or SQL Server area. Please come and find us if you need. And thank you very much.